In this lecture, which will hopefully be nice and short, we're going to be talking about evaluating functions. Now, a function is something that's written as, we've seen this before, of course, so it's written as like f of x equals something. So there could be anything over here. Well, not really anything, but technically almost anything. So, we've really already talked about evaluating functions before. Remember, we talked about whenever you're looking for a vertex, you have the vertex of a parabola, you have something, f of x equals something over here, and then the vertex is equal to see, what was it? It was negative b over 2a for the x component, but then it's going to be evaluated so it's going to be, oops, just a second. Okay, I forgot a parentheses. Okay, so what we're doing right here, what we're doing for evaluating functions is this right here. We took the negative b over 2a and we plugged it into this expression for x. So what this section is essentially a review. So for that reason, I'm hoping it'll go by pretty smoothly and easily. But let's go ahead and jump right into it. So whenever we have a function f of x equals something, and we're told to find f of a, or evaluate f of x at a, that means the same thing as find f of a. We take this something, the same something that we have up here, we take out all the x's and replace it with a, and then we simplify. So it sounds easy. Well, it may not sound easy now because it's been abstracted so much, but we'll get into some examples. And it is easy, but don't be overconfident. The real work is the simplifying part. So all we do is we have some like x squared minus 2 or something, and we take out the x, replace it with a, and that's a squared minus 2, and that's evaluated f of x at a. So if we have f of 1, then we'd have 1 squared minus 2, which is going to give us negative 1. So that would be f of 1. We've evaluated f of x at 1. So I didn't mean to jump right into an example already, but I guess there's no harm in that. So let's go ahead and jump into a pretty simple example. So let's go ahead and go to let's say we have f of x equals 3x minus 5. So if f of x is equal to 3 minus 5, and we're told to find f of 1.5. Oops, new line. So we're told that this is what f of x is, and we need to find f of 1.5. Okay, well, I'm just going to take the f of x, I'm going to scroll down. So I'm going to take the x out and put 1.5 in. So 1.5 in for x. So that means we're going to have that f of 1.5 is equal to 3 times 1.5 minus 5. And notice something. This is kind of a habit. It's not always necessary, but it's kind of a good habit. I put the 1.5 in parentheses here. And the reason why is because this is, when we say 3x, it's very important to understand this means 3 times x. So I put the 1.5 in parentheses because this means 3 times 1.5. Now if you put 3 dot 1.5, I put the parentheses back in there anyway. So if you did 3.1.5, normally that's going to be okay, but if you get the habit of putting it in parentheses, it usually cuts down on different problems later on. And we might see that in these examples, I'm not sure. So we have this 3 times 1.5 minus 5. Okay, I don't really like dealing with decimals. Fractions are a lot more versatile, so I'm going to replace that with 3 halves, if that's alright. So 3 halves minus 5. 3 times 3 halves minus 5. So this 3, this is the same thing as 3 over 1, and we can multiply the 3's and multiply the 1 times 2. So we'll get 9 halves minus 5. 9 halves, okay, well this 5, I'm going to replace that with a 10 over 2. Because that way we have a common denominator, the 10 and the 2 for each one. Let me erase that, that looks sloppy. Okay, so 9 halves minus 10 over 2, which is going to give us negative 1 half. Because you have 9 minus 10 is going to give you negative 1 over 2. So you can also write this as, and this is just as acceptable, negative 1 over 2. It means the exact same thing. So this, we have now evaluated f at 1.5. We just took in the 1.5, replaced x, and then simplified it down to negative 1 half. Okay, so now allow me to clear that off, and I will go on to another example. So, let's say we have g of x, and don't let the fact that this says g fool you. It means the exact same thing. G of x means f of x. It doesn't really matter. In fact, this could be g of t if we wanted it to, or g of lambda or something. All that really matters is where things are, not what specific letters you're using. So g of x equals 1 half x minus 3. So we have 1 half times x minus 3. And we want to find, now this is going to be a little bit different, but it's the exact same process. We want to find g of 6 plus g of b. Now this actually means, let's look back at the previous example. All we did for here was we put 1.5 in for x. For here, we're going to take we're going to put 6 in for x. Then we're going to put b in for x, and then we're going to add those two results together. So let's go ahead and do this separately. You don't really have to, but you could do it on a single line, but I'm going to go ahead and do it on two. So g of 6 equals 1 half times 6 minus 3. 1 half times 6 is going to be 6 halves. Which is going to be 3. Sorry. Minus 3 equals 3 minus 3, which is going to equal 0. So now we figured out that g of 6 equals 0. It's not always going to equal 0, obviously. In fact, I'm going to change this up. Let's do a variation of this problem. Let's change this 6 to a 5. So we want to find g of 5 plus g of b. So that means I'm going to go ahead and erase most of this. So we have g of 5 equals 1 half times 5 minus 3. So that's going to give us 5 halves minus 3. Because I just multiplied the 5 times the 1 half. Remember, this is the same thing as 5 over 1, so you multiply across. And this 5 halves minus 3, well, this 3 is the same thing as 6 halves. So now we have a common denominator. So we have 5 minus 6. It's going to give us negative 1/2. So that means we have g of 5 is negative 1/2. We just put 6 halves in for 3, subtracted 6 halves from 5 halves, and got negative 1/2. So let's go on to the next part. We have g of b equals 1/2 times b minus 3. We just took the b and put it in for x. So that's actually as simplified as this gets. 1/2 times b minus 3. But we're not looking for these individually though. We're looking for these two things added together. So we just take this and add it to this. So we have negative 1/2 plus 1/2 b minus 3. Let's go ahead and write that too as g of 5 plus g of b equals. So g of 5 plus g of b equals, here's g of 5, which is negative 1/2, and g of b, which is 1/2 b minus 3. And if it doesn't really hurt to put parentheses here, because what if this had been find minus? If this was find g of 5 minus g of b, then we'd have a minus here, and this minus would distribute. But since that's not what we're solving right now, just remember that g of b is the entire expression, so it doesn't hurt to put. In fact, I'm going to go ahead and do that in typing too. So we're going to have 1/2, negative 1/2. Let's go ahead and clear all that off. Plus, it's very similar to what I said up here. It's good practice to go ahead and put it in parentheses. So now we have negative 1/2 plus 1/2 b minus 3. Well, we don't have any negatives to distribute, so we can go ahead and just take out the parentheses. And I forgot to type in the negative. Okay. Plus 1/2 minus 3. Oh, 1/2 b, excuse me. 1/2 times b. 1/2 times b minus 3. So, this cannot be combined with anything because there's no other b terms. This, however, can be combined with this. We have negative 3 minus 1/2. So negative 3 minus 1/2 is going to be, it doesn't matter what order you do it in, is going to be the same thing as negative 6/2 minus 1/2, which is going to be negative 7/2. So that means what we have here is to combine these two terms, we get 1/2 b minus 7/2. So we just combine these two terms to get negative 7/2. So that means that this is going to be our answer. We have g of 5 plus g of b equals 1/2 b minus 7/2. Okay, so I have one more example, and I don't know how long I've been going, but hopefully this is going to be a pretty short video. So, for example, we have g of x equals 1/2 x minus 3. Okay, this is actually, remember, this is the same thing as before. G of x equals 1/2 x minus 3, but we're going to be doing something different now. Instead of finding g of 5 plus g of b, we're going to be finding... Oh, crud. Just a second. Okay, find g of 3a plus 1. So now, see what we're doing here? We're putting an expression into x. It's no longer just a number or a single variable. We're putting in an entire expression in for x. And it's really not that hard, but it does require some distribution, requires some, well, algebra. So, what we have is 1/2 times 3a plus 1 minus 3. So we want to go ahead and distribute this 1/2 to the 3a and the 1, which isn't too hard, so we'll just get 3 halves times a plus 1 minus 3. So 3 times 1/2 will give you 3 halves. Oh, I did not distribute correctly. I'm glad I caught that. That should be... So that should be 1/2 times 1 will give you 1/2, which is where we get this 1/2. So 3 halves a plus 1/2 minus 3. Okay, well, this 3 halves a can't be simplified any further, but these two can. So 1/2 minus 3 is going to be the same thing as 1/2 minus 6 halves, which is going to be negative 5 halves. So that means this is going to simplify down to 3 halves a minus 5 halves. So this 1/2 minus 3 will become negative 5 halves, or 3 halves a minus 5 halves. Okay, and that pretty much concludes everything from this particular lecture. Remember, it has a lot of algebra in it. That's why I'm kind of emphasizing that whenever you put this in here, you want to go ahead and put parentheses around it. Because especially, what if this was x squared? You know, if this was x squared, then you'd have to go ahead and square it out first. Okay, that concludes this lecture. I will see you in 11.2.